lecture, we will be studying about engine performance parameters. So an engine is described in terms of its efficiency. No? So in order to compare certain engine with another engine, we have these performance parameters. So this will tell whether our engine is superior with respect to the other engine. But before we proceed with those parameters, let us discuss first these three types of power. First is you have an indicated power, second is frictional power, and the third one is the brake power. Maybe you will already heard of the term brake power, no? But you're a little bit confused. Unsa ni siya? Okay, so the difference between these three is that the indicated power is the heat energy from the fuel that is converted to power and is used to drive the piston. So when you talk about indicated power, this is the power that is contained in this part of the engine, no? In this part of the engine. During combustion, the fuel releases thermal energy, and many of those energies are wasted, no? It is carried away by the cooling water, the coolant, no? And then energy loss in the exhaust. So kung i-minus na to tong mga losses, ang mabili na lang is what you call the indicated power. Kanang indicated power, muna siya magtulod sa imong piston panahog. The brake power, this diagram shows the distribution of energy. If the green bar represents the total energy in the fuel, the red part is the indicated power, no? So this large portion of the energy is lost in the exhaust, coolant, radiation, conduction, etc. And then the brake power, when you talk about brake power, muna na siya ang power available sa imong crankshaft, sa imong drive shaft, no? So that is the power available in the crankshaft. So usually kanang mga specifications sa engine, say for example, 50 horsepower. Pasabot ana actually is the brake power. Brake power na siya. Mo na siya power nga available sa imo ang shaft. No? When you say available, na minusan na siya sa what you call the frictional power, no? From the indicated power, the energy that is used to drive the piston, i-minus nimo ang frictional losses ana sa walls, sa iyang bearing, minus the pumping, the energy used sa imong mga auxiliary, no? Kaya na ang ganing imo ang crankshaft, daghan man kani siya auxiliary. You have the alternator, ang imo ang kaning imo ang camshaft, no? Kaning cam mechanism nimo sa imong valves. Ang energy nga gigamit ana is gikan pod sa indicated power. So i-minus nimo sa indicated power ang frictional power, ang mabili na lang is what you call the brake power. So muna siya difference ng 3. In diagram, muna siya ang this is another way of stating tong what we have discussed so far. Again, this is the total energy in the fuel. You subtract the energy losses, you will get the indicated energy or power. And then, from the indicated power, you subtract the frictional losses, you will get the brake power. Okay? Now, let's proceed with the engine performance parameters. The first parameter to indicate the performance of an engine is you call the indicated thermal efficiency. So the indicated thermal efficiency is the ratio of energy in the indicated power to the input fuel energy. Okay? So what this efficiency tells us is that it indicates how much or at what percentage of the fuel is converted to power. No? Okay, so in equation form, you have indicated power over energy in the fuel per second. Okay? So, kung taas na indicated thermal efficiency, meaning taas po ang efficiency sa engine. Taas ang na-convert niya nga power. Second one is you have the brake thermal efficiency. So the brake thermal efficiency is the ratio of energy in the brake power to the input fuel energy. So what this efficiency mean is that iyang i-compare ang how much is the useful power, no? Kaya ang useful nga power is kanina mga brake power, no? Mo jud ni siya ang useful nimo or ang power nga na-produce sa engine divided by the total energy in the fuel. Again, kung magkataas ang imong brake thermal efficiency, pasabot ana mas taas ang efficiency or mas nindot ang performance sa imong engine. Okay, so the third parameter is the mechanical efficiency. This is the ratio of the brake power to the indicated power. Okay, so what this efficiency tells us is that it tells us how much of the indicated power is converted into brake power. Okay? So in equation form, you have BP over the indicated power. So pasabot ani kung taas ang imo ang mechanical efficiency, pasabot ana niya taas og portion sa indicated power ang na-convert into brake power or useful power. Meaning ana na minimize nimo ang mga frictional losses or na minimize nimo ang frictional power. Okay, so in equation form, this is the indicated thermal efficiency, indicated power over the E, energy in the fuel. So this is the calorific value, no? Mass times the calorific value of the fuel. Volumetric efficiency tells us the volume flow rate of air into the intake system divided by the rate at which volume is displaced by the system. Okay, so in equation form, this is the actual mass flow of air divided by the theoretical flow of air, where the theoretical flow of air is density times N times the displaced volume. Kaning N is the number of power strokes. For a 4-stroke engine, this is equivalent to N over 2. And for 2-strokes engine, this is equivalent to N. Where N is the RPM, no? Ang imong angular speed. Tapos, the fifth parameter is the relative efficiency or efficiency ratio. This is the ratio of thermal efficiency of actual cycle to that of the ideal cycle. Okay? So that is the relative efficiency. It is a very useful criterion which indicates the degree of development of the engine. Okay? Degree of development. Sabot ani niya is that ang imo ang pinakataas nga efficiency man is the air standard efficiency, no? Kay imo man ning gi-assume nga constant imong specific heat. Of course, ang pinakataas is no. But no, kung i-compare nimo ang actual thermal efficiency compare sa air standard o makita nimo diri kung pwede pa ba i-improve ang imong engine, no? Siyempre, kung mas magkaduol sa air standard, meaning na-improve gud nimo ang imong engine, no? Imo man ni limit nimo. Okay. The very important parameter which is called the mean effective pressure is the theoretical constant pressure that is if acted on the piston during the power stroke would produce the same network as actually developed in one cycle. Again, in equation form, this is network for one cycle over the displaced volume. So, ang kaning mean effective pressure, this is a theoretical pressure, no? Kaya ang imo ang pressure sa imong engine nag-vary man na siya. No? During the suction stroke, ubos, pag-compress ni taas, until nga combustion, power stroke. So, mag-vary na siya. But, kung naamang kay work nga na-produce sa engine, kung i-divide out to nimong work divided by the displaced volume, ang unit nga resulting nga unit ani is Newton per meter square. So, this is a unit of pressure. So, no, ilang i-assume nga this is the mean effective pressure. Okay? So, kung mas taas imong mean effective pressure, mas dako, mas nindot ang imong performance sa imong engine. We have two types of mean effective pressure. You have the indicated mean effective pressure and the brake mean effective pressure. Ang pasabotan nila is that sa indicated mean effective pressure, ang gigamit nimo nga work is the indicated power. Whereas sa brake mean effective pressure is the brake power. Okay? Later on, ma-derive na to ni ahan gikan. Okay, these are the legends. Your L is the stroke area of the piston, ang A. N is RPM. K is the number of cylinders. Okay, the seventh parameter is the mean piston speed. Okay? So, ang mean piston speed nimo is 2 times Ln or 2 times the length of stroke times the RPM. Anong 2 man? Ano yung 2? Kay na siya gikan is that, di ba ang imo ang speed nimo is distance over time. Distance over time. So, in one revolution nimo, sa one revolution sa imo ang engine, pila man unsay length na na-travel sa imong piston. Ang imong piston travels from the top dead center padulong bottom dead and balik na pud sa top dead for one revolution. No, sa isa ka revolution. Meaning, muna siyang 2L, muna gi-times 2 nimo kay balik man sa naog sa una sa top to bottom, then bottom to top. So, munang 2. And then, ang kaning N, RPM nimo imo ang angular speed is in revolutions per minute. 8th parameter is the specific power output. So, this is the power output per Okay. Power output per unit piston area and is a measure of engine designer success in using the available piston area regardless of cylinder size. It is also proportional to the product of the mean effective pressure and mean piston speed. Okay, so the specific power output is power over power per area. Okay, so this is useful in comparing the power output of, say for example, you have two engine with the same piston area, no? So kung mas dako og specific power output, meaning mas dako siya og power produce. Okay, this is also equal to the product of the brake mean effective pressure and the piston speed times a constant. Okay, the ninth specific parameter is the specific fuel consumption. So this parameter reflects how good the engine performance is. Okay, so it is inversely proportional to the thermal efficiency of the engine. So brake specific fuel consumption and indicated specific fuel consumption is, so naa kay gitawag BSFC and ISFC. So mo na gitawag nga specific fuel consumption for brake and indicated power. Okay? SFC. Okay, so the specific fuel consumption, this is the equation, no? Fuel consumption per unit time per over power. So this parameter tells us how much is the fuel consumed per power. Okay? So it talks about the fuel economy, no? For this amount of power, pila man ang na-consume niya nga fuel. So makita nimo no nga economic or paano ni siya, mas tipid ni siya nga engine, no? So usually muna siya ginagamit pod no sa mga car owners, or usually in terms of kuan man mileage, no? For 1 kilometer pila ang ma-consume niya nga fuel. So isa na siya no sa mga parameters nga ginagamit para to compare a certain car model with another car model. No, kung depende kung unsa nga power mo gamiton. Kung brake power, ang result nimo is brake specific fuel consumption. Kung indicated power ang imong denominator, makuha also nimo is indicated specific fuel consumption. The 10th parameter is the inlet valve Mach index, or this is just the Mach number of the gas flow. Sa inlet nimo, inlet gas flow. Again, ang Mach number, unsa na siya nga number? Ang Mach number is mo na siya ang number that compares, no, i-compare niya whether kani nga gas is, ang speed ani nga gas is equal na ba sa speed of sound, no? So importante ng Mach number, especially when you talk about how high gas flow, no? Kung higher velocity ng mga gases, mga design ana. Simple naman isang Mach number. Ang Mach number nimo is just the gas velocity over velocity of sound, no? Iyara ginang i-compare kung Kung ang value gani aning z, when z is equal to 1, meaning ana, ang velocity ana nga gas is equal na sa Mach, equal na sa velocity of sound. Again, ang kaning alpha, this is just a function of temperature. No? This is just a function of temperature. So this is the equation. Ang wherein ang imo ang U is A over P over CI over AI, piston speed, where A is kaning mga area na siya, piston area, nominal intake valve opening. Okay? And this again, these are the legends. So the question is, unsay importance aning inlet valve Mach index? So ang inlet valve Mach index, na siya relation sa imong volumetric efficiency. Again, kung magkataas gani imong volumetric efficiency, di ba, magkanindot ang performance sa imong engine. Meaning ana, pasabutan na maayo ang pagsulod sa air padung sa imong engine, pagsulod og paggawas. No, kay unsa may makahinder kung dili makasulod ang imo ang air, di gamay ra kag power nga ma-produce. Kay dili ma-met ang required na stoichiometric ratio. No? Kay okay, so kung magkataas galing mo ang inlet valve index 1.2. So meaning ani ang velocity padung sa imong inlet is taas na kaayo, exceed na sa velocity sa sound. Ang velocity sa sound is around 200 plus meters per second, no? So usog na kayo siya. So dako kay baba sa iya ang volumetric efficiency 1.2 na imo na lang 0.55. Okay? So it is found out nga na diri sa 0.55 ang maayo nga or optimum performance. So mo na targeton karon sa imong design dayon, no? Na dapat sa imong inlet nasa 0.55, meaning half sa speed of sound. The 11th parameter is the fuel to air or air fuel ratio. Again, very important ni siya. This is the equation, no? Ang imong air to fuel ratio, a mixture that contains just enough air for complete combustion of fuel in a mixture is called chemically correct or stoichiometric fuel-air ratio. This is the term, stoichiometric fuel-air ratio, meaning pag-balance nimo no sa iyang chemical reaction, mo jud to ang amount sa ano yun nga chemically correct amount sa air nga dapat i-supply nimo sa imo ang engine. A mixture having more fuel is what you call rich mixture. And mixture that contains less fuel, no, kung gamay ra pod ang fuel, is a lean mixture. The ratio of actual fuel-air ratio to the stoichiometric fuel ratio is called equivalence ratio. No, kung 1 gali na, meaning kung ganing equivalence ratio kung 1 pasabotan na ang imong actual nga gi-supply sa engine is equal to the stoichiometric fuel-air ratio. Kung greater than 1, meaning ana rich mixture, daghang more fuel imong gi-supply. Kung less than 1, lean mixture. Lastly, you have the calorific value, kapilan ni nga parameter. Ika-12 naman din eh. Mali ni. 12 na siya. Okay. Okay. The 12th parameter is the calorific value. So it is the thermal energy released per unit quantity of fuel when the fuel is burned completely, and the products of combustion are called back to the initial temperature of the combustible mixture. So other term used for calorific value is you have heating value or heat of combustion. So na kay ma-encounter nga higher calorific value and lower calorific value. So unsay pasabot ana? Higher calorific value occurs when the products of combustion are cooled to 25 degrees Celsius and practically all the water vapor resulting from the combustion process is condensed. No, kung mo-condense nga mga water vapor sa imong products of combustion, kung pag-cool nimo, makuha nimo na nga value is higher calorific value. If not, kung mo remain na sa as vapor form, lower calorific value imong makuha. Okay, so how to determine the indicated power and brake power of the engine? First is, for the indicated power, ang anong indicated ang power and term ano niya is, makuha magod mo na siya using this, what you call indicator diagram. So, ang indicator diagram is just a PV diagram and then i-plot ang pressure for every process sa imong engine. And then, since this is a PV diagram, ang kaning area nga na-enclose aning part or aning area is represents the work, no? Ano gitawag nga indicated power. So, mo nang equation niya. So, asa man nagikuha, no? This is the mean effective pressure, volume displacement times N times K over 60,000. Unit is kilowatt. So, gikuha na siya from this is the equation of the indicated mean effective pressure. So, di ba? That is just indicated work per cycle. Okay. For one cycle man na, over the displaced volume. So, since kung ato nang i-transpose ang power kani siya nga term, this will be equal to indicated mean effective pressure times volume displacement. And then, since work pa man to mahimo ni siya nga power if we divide this by, or if we multiply this one by cycle per second para cancel po ng cycle. And mahimo na din yung work per second or work over time, mo na ng power na siya. Now, ang imo ang indicated power is just PIM times VS or the volume displacement times N, where N is the cycles per second. Kaning imong volume displacement is equal to length of stroke times the area of the piston. Since ang imo ang kaning N nimo is in revolution per minute naman na, convert na nimo to second. Unang natong 60. And then ang kaning N for 2 stroke, ang 1 revolution is equal to 1 cycle. No, kan 2 stroke nimo, no? Isa ka tuig sa crankshaft, complete niya ang isa ka cycle. For 4 stroke, sa isa ka revolution, katunga pa sa cycle. So, mo ng N over 2. Therefore, the indicated power is indicated pressure times displaced volume times N times kung pila ka book number of cylinder, no? Kung pila ka book number of cylinder. But, based sa equation kay anong na ay 1,000. Na siya 1,000 kay ang kaning imo ang mean effective pressure naka-newton pa man naka-newton. Para mahimong kilonewton, i-divide na to na sa 1,000. So mo na dayon ni. No, so timanan lang ninyo ang sa unit nga gigamit. Ang mean effective pressure is in Pascal. Ang N is in RPM. Okay, mo ni ang yang legend. Okay, for the brake power, usually ang brake power, no, kay mo naman na siya ang power sa imong nasa imong shaft. So the way to get the brake power is you use prone brake, no? Prone brake nga instrument. So mo siguro nga gitawag ng brake power kay prone brake ang gigamit ano no. So ang prone brake concept ana niya is mura ra gud ni siya og kanang brake, diba? Ang brake nimo kay para ma-brake na nimo ang imong bike na ay frictional material nga murab dito sa imo ang wheel, no? Sa imo ang mags nimo. So in the same way, if this is the flywheel na kay frictional nga material, frictional band na material, no? Imo nang ipalibot sa flywheel, and then naa kay force nga i-apply. Of course, calibrated po na imong force para makita nimo. No, kung applyan nimo force, simpre mo dikit ning frictional material sa flywheel, mo ni maupo sa imo ang rotation. Okay? So mao ni siya ang mga available nga kaning force nimo kay calibrated na may scale ang R na apod. Therefore, ang imo ang power man is torque times omega. So ang torque is R times F, or is just equal to kaning small r times frictional force. So kung multiply na to ni siya og angular speed, ano na makuha na to nga ang brake power is 2 pi r F times n over 60,000. Okay, so let's have a sample problem. The cubic capacity of a 4-stroke over square spark ignition engine is 245 cc. The over square ratio is 1.1. The clearance volume is 27.2 cc. Calculate the bore, stroke, and compression ratio of the engine. Okay, so if this is your engine, this is the ang volume displacement. Kaning naka-black. Kaning naka-blue mo na imong clearance volume. So, ang length aning mo niya mo na gitawag nimong length of stroke L, and kani siya is bore D. So mayon kag over square, pasabot ana mas dako ang imo ang bore over sa length nimo, di ba? Mas taas ang D. So this is just equal to D over L. Bore over stroke ratio 1.1. Okay, kung 1 ni siya, pasabutan na equal ang L o D. So since the displacement volume is 245 cubic centimeter, this is just equal to area sa piston pi d square over 4 times L. Multiply na to nag D over D. You get this equation. Okay, naaman kay L over D over L. So may mo ning pi d cube times 4 over opposite ani. So divide mo ning 1.1. Therefore, makuha nimo nga D or the bore is 7 cm, ang L nimo 6.36 cm, and the compression ratio, again, ang compression ratio is kani nga volume, total volume over clearance volume, which is 10. Okay, so let's have another example. A 42.5 kilowatt engine has a mechanical efficiency of 85%. Find the indicated power and frictional power. If the frictional power is assumed to be constant with load, what will be the mechanical efficiency at 60% of the load? So one key para mansira nimo ni siya is to determine unsa ni nga power, indicated or brake power or frictional power. So kaning 42.5 yun niya, a 42.5 kilowatt engine has a mechanical efficiency of 85. So kung may kag 42.5 kilowatt engine, that is the brake power. And then mechanical efficiency is BP over IP 0.85. Yun niya, find the indicated power. So imo running plug in dire. Indicated power is BP over 0.85, which is 50 kilowatt. And then find the frictional power. So ang frictional power again is IP minus BP, which is 7.5 kilowatts. For the second question, if the frictional power is assumed to be constant with load, so constant radon is 7.5, what will be the mechanical efficiency at 60% of the load? So, yung kag 65%, so 60%, so brake power at 60% load. 60% lang gigamit. So, therefore, so 42.5 times 0.6, which is 25.5 kilowatt na brake power. And indicated power kay mechanical efficiency man kani man gipangayo, so that is BP over IP. So IP is 25.5 plus 7.5 is 33. Kuha na dahil nimo ang mechanical efficiency, which is 77.3%.